Now that we've looked at linear functions, we can move on and talk about quadratic functions. A quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c. And an example of this might be x squared plus 2x minus 8. Now, if we want to graph quadratic functions, we're going to get the shape of a parabola. And there are different ways to graph quadratic functions. We do not have time to look at all of the different methods right now, but I want to look at just a couple of things because these things will be useful later on. When we have a quadratic function in this form, we can find the x-intercept by plugging in 0 for x. And when we do that, these terms vanish. And whatever's left, in this case, -8, is our y-intercept. So the y-intercept is going to be down there. And then if we want to find the x-intercepts, we can set our function equal to 0 and solve for x. So we can say x squared plus 2x minus 8 equals 0. And we can factor that trinomial on the left. Something like this is going to factor into a product of two binomials. And to get the constants, we need two numbers that have a product of -8 and a sum of +2. Those are going to be +4 and -2. And if we set each of these equal to 0, x plus 4 equals 0, or x minus 2 equals 0, and if we solve these for x, we get our intercepts, x equals -4 or x equals +2. So we can plot those on the x-axis, and that gives us 2 more points. You might be thinking, well, why aren't we just making a table of values? That will give us points as well. And you're right that that will give us points, but oftentimes the intercepts are the most important points. If this is some sort of a profit function, not that this would be the shape of a profit function. A profit function would actually be a quadratic where there was a negative in front of the x squared. But if we had a graph that was giving us profit, the x-intercepts would be when the profit is 0. Those are our break-even points. And the y-intercept is generally what happens when you sell 0 objects. So that's also an important point. Whenever our function represents something that's a real quantity, the intercepts are often some of the most important points. So anyways, we have these 3 points, and we could try and draw a parabola between them, but we don't actually know what the lowest point is. This may or may not be it. And so to find the lowest point, we want to find the vertex. That is going to be our minimum value in this case. It would be a maximum value if we had a parabola opening downward. And there are different ways of doing this, but if you want the vertex, the x-coordinate comes from the opposite of b over 2a. So in this case, the value of b is 2, and so that is going to be a -2 there. And then in the denominator, the value of a is 1, because x squared is the same as 1x squared, and 2 times 1 is 2. And so the x-intercept of our vertex is going to be -1. And if we want the y-intercept, we can just evaluate the function at -1. So that's going to be -1 squared plus 2 times -1 minus 8. So that'll be 1 minus 2 minus 8. And when we do that, that gives us -9. So our vertex is going to be at the point -1, -9. We can plot that right here. It's a little bit below how far our grid goes, but we can still plot it. And once we have that, we can draw in a nice parabola with the correct vertex that goes through the intercepts that we've got. and that is our graph of f of x equals x squared plus 2x minus 8. Now, there's so much more we could say about quadratic functions. In fact, in a pre-calculus class, oftentimes we spend a whole week or even 2 weeks talking about quadratic functions. So this is just a very, very quick review. Hopefully, some of this seems a little bit familiar. I'm sure most students don't remember all of these details from memory from their algebra and pre-calculus classes, but I'm just trying to jog a few little memories here and there in hopes that these will support you moving forward in the class.